What if you could teach a computer to learn, not by handing it some giant rule book, but just by letting it figure things out for itself? I know, it sounds a little like sci fi, right? But it's happening all around us, every single day. This is the amazing world of machine learning, and you might be surprised to hear that it all started in a very unexpected place. This definition right here is just perfect. It's really where our story begins. It comes from a real pioneer, a guy named Arthur Samuel. And what he did, way back in the 1950s, basically laid the groundwork for so much of the tech we rely on today. Yep, you heard that right. Checkers. Now, here's the kicker. Arthur Samuel himself? He wasn't a very good checkers player. I mean, he couldn't program the computer with his own genius strategies because, well, he didn't really have any. So how on earth did he manage to create a program that could play like a master? Well, he let the machine learn from experience. Samuel's program played tens of thousands of games against itself, just over and over and over again. And with every single game, it started to recognize patterns. It started to figure out, okay, these board positions usually lead to a win, and those ones, they usually lead to a loss. It was learning strategy without ever being explicitly told the rules. And this is just the perfect illustration of what machine learning is all about. The student became the master. The program got so much practice, it saw so many possibilities that it completely surpassed the skill of the human who built it. A truly mind-blowing result, especially for the 1950s. Okay, so let's fast forward to today. Machine learning is creating just a tremendous amount of economic value. But get this, an estimated 99% of that value, it comes from just one specific type of machine learning. So what is it? To understand that, you got to know there are two main paths machine learning can take. The first one is called supervised learning. The easiest way to think about this is that it's like learning with an answer key. You give the computer an input, X, and you also give it the correct output, Y. The other path is unsupervised learning, and here you just give it a ton of data, just X, and you basically ask it to find something interesting on its own. So let's start with supervised learning. This one is the real workhorse of the industry. It's the one responsible for that 99% figure we just saw. It's absolutely the most common and impactful type of machine learning you'll find out in the real world. So here's the core idea. In supervised learning, the algorithm is trained on a whole data set where the right answers are already known. It learns by studying thousands or even millions of examples of an input, X, and its correct output, Y. It keeps doing this until it gets good enough to predict the Y for a brand new X it has never seen before. And you really do see this stuff everywhere. When your email filters out spam, that's supervised learning. When your phone understands what you're saying and turns it into text, that's supervised learning too. Those creepy specific online ads, self-driving cars identifying stop signs, even factories spotting tiny defects on a production line, it is all powered by this one method. Now, inside this supervised world, the algorithm usually has one of two main jobs to do. It's either trying to predict a specific number from a whole range of possibilities, or it's trying to sort something into a distinct group or a category. We call these two jobs regression and classification. So regression is all about predicting a number. Like, what's the price of a house going to be? It could be thousands of different values. Classification, on the other hand, is about predicting a category. Like, is this tumor cancerous or benign? It's one or the other, a distinct choice. So let's take a look at regression. Imagine you have a ton of data on house sizes and what they sold for. The algorithm chews on all that data and learns the relationship between them. It's basically fitting a curve to that data. Then, when you ask it about a new house size it's never seen, it uses that curve to predict a specific price. And for classification, think about medical diagnoses. An algorithm is given a bunch of data on tumors, say their size and the patient's age. And it also knows whether they turned out to be malignant or benign. It learns how to draw a boundary separating those two groups. So when a new patient comes along, the system can predict which side of that boundary they're likely to fall. Okay, so that's what it's like to learn with an answer key. But what happens when you don't have one? What if you've just got a big, messy pile of data? That's when we take that other path, unsupervised learning. This is where the machine has to find the patterns all by itself. With unsupervised learning, you just give the algorithm a pile of data. There are no labels, no right answers. Its whole job is to just explore all that information and see if it can discover some kind of interesting structure or pattern hidden inside. It's not about prediction, it's all about discovery.
You can almost think of it like a digital detective, sifting through all the evidence to find connections. And one of the most common techniques it uses is called clustering. A fantastic real-world example of this, something you've probably used, Google News.
Think about it. Every day, Google's algorithm scans hundreds of thousands of news articles. It has no idea what the big stories of the day are, but it might start to notice that a whole bunch of articles all have the words panda, twin, and zoo in them. So the clustering algorithm groups these articles together, creating a news topic all on its own, without any human ever telling it that panda twins are an important story. And this ability to group the unknown it's unbelievably powerful. It allows us to find these hidden structures in some of the most complex datasets in the world.
I mean, scientists use this for analyzing DNA data to find genetic groupings in a population that they never even knew existed. Companies use it to segment all of their customers into different market groups based on their behavior. It can even be used for things like fraud detection, just by clustering all the normal transactions and then flagging anything that falls outside those clusters as a weird anomaly.
Let's go back to that customer example. An online learning company might run a clustering algorithm on its user data and suddenly discover three totally distinct groups: people who are there just for the sake of knowledge, people who are focused on career development, and a third group that's just trying to stay updated. This helps them serve their community so much better, all thanks to an algorithm that found a hidden pattern. So let's just put it all together real quick. On one side, you've got supervised learning. It gets labeled data, our answer key, and its whole goal is to predict an output. On the other side, you've got unsupervised learning. It gets unlabeled data, and its goal is to be a detective and find hidden structures. It's kind of the difference between being a student with a textbook and an explorer with a map. From a simple game of checkers, all the way to segmenting the human genome, machine learning gives computers the ability to learn in ways we're only just beginning to understand. So the real question is, as these systems get better and better at finding patterns that are invisible to the human eye, what new, fundamental truths are they going to teach us about our world?